Okay, so I need an on-air sign. We're on the air here. So we're looking at 4.6, and I can't say that because it may not be 4.6. You know, in the future when they're flying around in hovercrafts and stuff. So this is going to be investigation. Where'd it go? There it is. This is investigation 7, part 6. Part 6. And we're looking at number 2. Now I know my studio audience hadn't had a chance to look this over yet, but we're going to go through it together. Hope you guys can see okay. 500 kilogram rocket as a propulsion force, and we'll call for this one on Monday. And this videos are going to go out to the homeschoolers as well. So, and my nephew in Germany, so they may not have a call on Monday. All right, so 500 kilogram rocket has a propulsion force of 8,000. So the first thing I'd do, go ahead and draw a little picture, a little free body. It's going to be simple. These are simple free bodies compared to what we were doing, but now we're applying numbers to it. So we have a propulsion force, or a force of thrust, of 8,000 newtons. And that's got a mass of 500 kilograms. So my mg down here, and the m is 500 kilograms. And so it has enough fuel to keep this propulsion for 15 seconds. So my t is 15 seconds. Different color since it's not a force. 15 seconds. Off the launching pad. At this point the rocket shut off. How far off the launch pad will the rocket be when the engine shut down? So there's a process. You can read through the whole thing. The rocket's going to go to a certain height. The engine's going to cut off. It's going to keep going up. And it's going to free fall back down. So it's a good review problem because a lot of those things we've learned. How far off the launch pad will the rocket be when the engine shut down? Anybody got an idea what we should attack this? We got to find delta x, which is it's delta y, right? But we're not using blue mirror. Why don't I use blue mirror?
Because gravity's already in there, in the force.
Well, yeah, because a lot of students do want to use blue mirror to solve this. Those are kind of me that will help.
Free fall.
That's not free fall, right? And so blue mirror is very limited. Be extra careful when you use a blue mirror equation, because it's got to be free fall, and that's not that often. So I'm going to use orange mirror, this time tilted all the way so it's vertical. So I suppose, anybody got an idea where a good place to start? When you're given a free body, once you do free body, what's a good next step? Find acceleration. So F equals ma. So let's go ahead and do summation of forces, and it's really forces in the y. We have no x direction. Equals MAY. And so I have 8,000 newtons minus, and it's 500 kilograms times 9.81 meters per second squared, equals my mass, which is 500 kilograms, times what I'm trying to find, A. Okay, so therefore, do a little quick math here. I should already have this figured out. Therefore, A is, I got it right here. So Martha Stewart action here, and I find that A is 6.2 meters per second squared. Now, if you're at home, you can pause this and prove that for yourself, but you'll get 6.2 meters per second squared. Now, what do? I got my acceleration. I know that rocket's going to have that acceleration for 15 seconds. So
orange mirror, second.
Now just orange mirror, right? Which one? Second, first, third?
Second.
Second one, because I'm trying to find. Okay, so I have. I'm going to do it this way. I realize it says X up there, but we're in the Y direction. So we have delta Y is equal to V naught Y T plus 1/2 A sub Y T squared. And I'm trying to solve. I know my V naught off the launch pad. That whole thing is going to go to 0. So I got I plug and chug now. I'm going to plug in 1/2 and then I'm plugging in the 6.2 for A. I'll plug in my 15 seconds for T. So that's what, 225 times 6.2 times a half. And my delta Y will end up being, voila, 697.5 meters. So that thing is going up, about a half mile into the air. And that 15 seconds got a half mile off the ground. Okay, now part B says what with the rocket's upward velocity at the time the engine shut down. So how fast now is it going? And let's go to the next page. So 2B, how fast is it going at that point? Now which orange mirror do I use? Third. So now I have, well, I could use third. Yeah, third is what I did here. So V final Y squared equals V naught Y squared plus 2A delta Y, 2A Y delta Y. And so plug and chug again, V naught is 0. And I'm going to get, just in symbol wise, V final equals the square root of 2AY delta Y. So I'm going to plug in my 6.2 for that. I'm going to plug in my 697 now. I just got 0.5 meters for that. And I'll get 93 meters per second. So once it reaches that height, it's going at 93 meters a second, very fast. And now it says, then C says what will be the maximum altitude the rocket will achieve. Okay, so how do I figure out how high it goes? I already know it's at 697.5 meters, but now the engine's cut off. Well, now what equations do I use?
Blue mirror.
Now I use blue mirror because now it's in free fall. Now it's in free fall with an initial upward velocity. So it's a whole different problem essentially. I have a velocity to begin with, and that velocity is 93 meters per second. And now I'm going to use blue mirror. Should do it in blue here. Now it's blue mirror time. Because it's rising at 93 meters a second, and then the engine's cut off, so it's going to come up and then reach its apex and then come back down. And the question is, I already know it's gone 697 just to get to that point, so I'll have to add 697. I'll have to add that on at the end. 697.5, and then I want to tack on however much it goes up as in free fall. So which blue mirror do I want? Third again? Third or second, but third's probably easier because I don't know the time, but what's the velocity at the apex?
0.
So it's a special third. So I'm going to use a special third where I have, so I'm going to say V final Y squared equals V naught Y squared minus 2G delta Y. But this time it's really apex. So if I'm at the apex, I'm going to know that is 0. So I have 0 equals now my 93 meters per second minus 2 times, now the only force acting on it is, the only acceleration on it is gravity, and 9.81 meters per second squared times my delta Y, which is I'm trying to find. I should have went ahead and solved for the symbol Y's, but I got nervous and plugged my numbers in too fast. I got ahead of myself. That's okay though. So take the 93, bring it over here, makes it negative 93 divided by 2, or 19.6, and I got my delta Y. And so I'll let you do that at home, and delta Y ends up being 441. But that's not the answer they give us. 441.3 is not the answer you see at the bottom of the page. Why not?
You have to add
Because you have to add this. So it's really this plus this. When I add those two up, I'm going to get 1139. So this thing will get to about 1.4 or 1.14 kilometers. So not quite a mile, but pretty high up there. Our rockets and our rockets will go higher than that, but well, no, it won't. We'll go around 3,000 or 4,000 feet, so a little less than that. Okay, and then finally 2D says what's the rocket's total time of flight? How are we going to figure that? 2D, how would I find total time of flight?
This until it hits the ground.
Right, this is until it hits the ground. This is all the way from the top. So now now it's a three-stage problem. We have this, we already know that's 15 seconds. That's when the rockets are firing. Then we have the time it takes to get to the apex, then it's going to fall back down. So we have, and the time down is not the same as the time up, right? Because on the way up you had those rockets attached. So now we got to figure out the time, call that T2, that's T1. And then T3 will be free fall from the apex back down. Now, or we could just do it all in 2 steps. We can go ahead and let's just do that. Let's go ahead and say, okay, it's a free fall problem. And I start off with my initial velocity. I want to know my total time now. Because then what's my delta y going to be? Ultimately? Negative 697. Now it's negative because I end up falling below. So negative 697. So I really don't want to do it T3. I'm just going to do it all as T2. So which blue mirror would you suggest?
Do the second.
Oh my goodness. Okay. Looks like we need a second, but it's going to involve a little quadratic formula. So I have my delta y. We'll go through it quick. V naught yt. We're almost done. Minus gt squared. And so let's go ahead and plug in numbers. Negative 697.5 meters equals 93. Okay, we're going to ignore my units because I'm going to run out of room. So 93t minus 1/2 times 9.81 times t squared. So now it's quadratic formula time, right? So now you take your blue mirror quadratic formula and we'll just go through and plug in. T ends up being, through blue mirror, 93 plus or minus the square root of 93 squared minus, I was doing this the old-fashioned way. Okay. Which is 4 times 1/2 g is just 2g, right? Yeah. Times 2, 9.81 times negative 697.5 because I'm falling. And the old rule is inside the radical I don't need to see units, it's too messy. And then divide that by 9.81 meters per second squared. And punch in, and t ends up being 24.7 seconds, but that's not your answer. Why not?
15.
Okay, so we add our 15 to that. We have a total of 39.7 seconds was our entire flight of our rocket. Now we're assuming no prevailing winds. Actually, winds don't matter. Well, if it's a gust, it does. No up thrust, no down thrust. About 40 seconds flight of that rocket. 2E, if you want to do that, that's extra credit. Take a piece of graph paper or 3 pieces and draw the trios that go with this fairly complicated motion. All right, channel was turned on.
Oh shoot!
The red light's not on there.
Yeah, it's right there. All right. Okay. So let me show my audience here.
Yeah. Yeah.
So one day your son will see that. Or at least your little brother.
Let me get a.
If you have one.